Hi guys. I know there is a bit of publicity around, and I've been posting a lot on social media groups that something is coming on 3rd December. Why did I select 3rd December? Well, I like to call these tags 3D tags, where you combine 3D appliances or laser melted appliances with orthodontic tags, complete palatal approach. I'm gonna try and give you an introduction of what, how, and why it is different from the regular tags available in the Indian market. These are no inventions or eureka from my side. There are quite a few companies around the world who are making something similar, but I hardly think any of them are available in India except for one. Let's not take names there, but not the full armamentarium for digital workflow is still available in India. We tried a lot. I did talk to quite a few companies. They needed some minimum order quantity. They needed a dealer plus the recent drug license regulations. It had to be filed and it was a long process. After working really hard behind it, I like to find solution to problems, and I ended up designing, using, reincarnating, and improving them. And I feel now they are ready for general use if any one of you do like them. So, as most of you would have seen my presentation, a typical digital workflow would look something like there is a hyrax. You place it in the center of your intraoral scan. You design arms around it, send it for laser melting, and laser weld the hyrax on it. You all know this. I'm just giving you a brief introduction of my journey, how I came to these new tags. We designed a lot of palatal expanders. You also know me for the AD plates. Dr. Abhishek and myself, we had designed something similar to this. Let me get my marker on. Yeah, we designed something similar to these that can be soldered or laser welded on the back of a normal hyrax, and you can convert any hyrax into Marpe, right? But what was happening most of the times, as I've always told you, that mini pins or tags were failing. We looked into it where we should exactly position it. T-zone, superb. I've had great success with it so far. So we decided we place our tags in T-zone. Okay. MSC is a gold standard. When we talk about Marpe, it is a thoroughly researched product. But if you try to place it digitally, you don't have freedom where your tags will go. They are hooked with the body and they move together with the body, right? You cannot place them like this, or in different directions. So that's a limitation if you're thinking of digital planning, according to me. Okay. And then there is a very nice article which highlights the fact that compared to monocortical, if you have bicortical anchorage of the mini implant during your MSC, you get good parallel expansion, more skeletal effects, and less dental effects. Right? We can see that from the conclusion here. So keeping these things in mind, we designed a workflow which could be used by everyone. There are 5 basic steps that we talk in that article. You scan or take an impression, clean, make a base digitally. You convert your cbct to 3D STL file, superimpose both of it. So now you have an intraoral scan on which you design an appliance, and there's a cbct superimposed. So you know exactly where to place your tags or mini pins or screws, whatever you like to call it. You design the appliance around it and you send it for metal 3D printing. So this is the design example that we have shown in the article. What you need to see is, we have kept our mini pins away from the roots, first thing. Second, because of the size of the body of the hyrax, it stays away from the base of the palate, but you can adapt the collar of your tags pretty well to the palate, right? You all know this. Most of you who have attended my lectures so far, you have seen this, right? Parallel tags, everything. You prevent them from collision, you can measure the distance, you can see it in individual slides of DICOM that we have good bicortical anchorage, first cortical plate, second cortical plate, and you can limit its penetration in the floor of the nose to as minimal as possible, right? So keeping these things in mind, we used a lot of appliances. This is the day we bonded the appliance. We expanded, we aligned and leveled, and we finished the case like this. Okay. This is how we had started: bilateral posterior crossbite, anterior crossbite, highly placed canines. This is how we finished it. Now, the important part of today's presentation is not this. It is the D3D tats. Okay. So once you have once you have seen this much part of my presentation so far, I would come to a point where I would say, what if I had this technology couple of years before I did this case? Instead of designing an appliance like this, I would have created a full band. For skeletal class 3 correction, I would have given arms on the buccal side, whereas in the previous case, we had done reverse class 3 twin block. Okay. We give slimline hyrax for distalization, position the tats, and combine the whole body. So this was my hypothesis, that I would work like this one day if I get a case. Okay, same skeletal class 3, dental class 1, where you need distalization, transverse, and AP correction, everything together. So this was one of the cases where I got the chance. I started, but I could not finish it. It was a dropout. By the time we finished transfers, the maxilla moved downward and forward. The alignment looks pretty much okay. You know, patient accepted it and she said, I don't want anything else. Somehow it stayed in dental class 1 also. So lucky patient, and I thought I missed an opportunity of distalization. And I used to show this, that distalizing with palatal tads is really nice because you just don't limit yourself to distalization. Okay, see, if you have a situation like this, fine, observe this. Okay, this is the direction in which you'll open the hyrax and you'll get distalization. Now say if you reorient the hyrax, okay, you see it from this side. Now this is the direction in which you get distalization. Fine. Now suppose you tilt your hyrax a bit like this. You can do distalization with open bite correction. You will get intrusion of the molars. The other way around, you can, correct the deep bite, extrusion and distalization of molars. So it sounded very easy and convenient. And we did a case with that. And see, we started like this. We got distalization and we started with aligners. Now, what I want you to observe is, see the amount of hyrax that was open. See the amount of distalization that was achieved, right? And see the body of the appliance here and the body of appliance here. Now you can see it in two ways. You can feel that the palatal mucosa has overgrown, and that is why we're not seeing the body of the appliance. But when we compare this here, okay, can you see the appliance has gone down? The neck of the tad is exposed here. You can see it clearly here. Here. So this was alarming for me. Something was not working well. What was it? We tried to look into it and we thought, let's change the appliance designs and everything, but we realized no, that's not how it works. So this is the transverse cross, this is the cross section to, see how the appliance works. So when you have a distalization force, there is an equal and opposite mesial force acting on the appliance, right? So what happens? Because the appliance is hooked here with tads, there's a moment created. Okay. And because the appliance is here and the tads are on top of it, the appliance loses and goes in. And you get intrusion of the appliance. So the resultant, you want distalization, but because this moves, you get distalization and extrusion. Now that digitally and practically, clinically, it's not predictable. You plan something and something else happened. It should not happen that way. That's not the reason you shift to digital technologies. You shift to digital technologies so that you can improve on yourself and get things more predictable. So what is the option here is, we need a wedge support here. below the appliance. Okay, that will hold the appliance when it is applying the distal force and prevent the intrusion of the appliance. So we studied quite a few TADs from different companies, and we realized we need something that is two-piece TADs. Okay, these are the different designs that we tried. We even tried doing 3 TADs before giving up. We thought these will intrude and the head of the distal implant will prevent the appliance from going in the anterior part, but it didn't happen. The whole appliance went in. Okay, so this is the solution. You create two-piece TADs, D3D TADs. 3rd December, Digant Thakkar, you correlate anything, digital 3D TADs, synchronizes everywhere. So this is the cover screw on top, and this is the body of the mini pin. You create a surgical placement guide. You place your TADs using the surgical placement guide. Okay, this is how we do it clinically. Guide, both the TADs are placed. New scan is taken. Appliance is designed on that scan, and appliance is placed in patient's mouth. So we reached 1925 TMA for 2 months before we did this scan, right? And placed the appliance. We wanted complete alignment and leveling first. Then we wanted to correct the subdivision. So this is how we started. This is the initial ray of hope when we see distalization and we really like it. Okay. This is the end of distalization. See the amount of hyrax opened and the amount of space gained. These are drifting just from the fibrous pull of the mucosa. Okay. And this is today's photograph. We're able to complete the segment distalization. This is the amount of arch length we gain by distalization. This is good. Yeah. That's the amount of distalization we saw. So two-piece TADs work. We tried it in lots of cases. We have had our fair share of success and failure. But let's see everything. Okay, it's not just TADs that we have to make. We have to see a lot of things of how they work and how individual step goes about. So this is the armamentarium you'll get. This is the torque wrench. Observe the black mark here. I'll show you the importance of that over the period of presentation. This is the hex driver. It is used to open the cover screw. Contra-angle driver. I personally am not too happy with placing the TADs with that, but to remove the TADs, this is very convenient. It's optional in the kit. If you want it, you take it. If you don't want it, you can avoid it. And these are the TADs, the final iteration. So this is the torque ratchet. Okay. So the easiest thing is it makes it very convenient for you to place the mini pins in palatal mini pins in patient's mouth using a surgical guide and a ratchet. You know, you sit 12 o'clock to the patient, you just move your hand like this. I'll show it to you in the video, and it just places your TADs. Otherwise, if you're doing things palatally, here's patient palate, and you will be going like this inside the palate to see where you're exactly placing your TAD, right? Second thing, why did we go for this? So when I was using IZC and buccal shelf generally, I have very high failure rate. Somehow they never worked in my hand, and I don't say that the system is bad, but the system didn't work in my hand. I could not adapt to it, and that's why I looked for a way out. Okay, so whenever I used to rotate and place it, okay, when I'm placing on patient's left, patient will turn and I'll place it. It was very convenient for me to place it. But when I'm placing on patient's right, that is quite near to me, it was getting difficult for me because my hand comes pretty close to me while rotating and inserting it in, and my wrist used to pain sometimes. You know, if you have done 3-4 times in a day, next day you have to walk with a cufflink. So I wanted something where least pressure is applied on your working hand. It has to be super comfortable. Okay. This is the driver that goes in the torque ratchet. These are the TADs, 2x10, 2x12. Initially for launch, we are only going ahead with 2x12. Palatally, that is the most common size I've seen that is being used to get good bicortical penetration. And this is how, this is the torque ratchet, this is the driver, it goes in the ratchet, and this is how the mini pin sit in it. Now this mini pin sits in it without the cover screw. You don't place it in the ratchet with cover screw. The cover screw won't go inside the driver at all. Okay. And you have the amount of force or the torque that you are looking for. So if you turn this, okay, tight or loose, you can alter the amount of torque that would be applied while you are rotating to place it. Okay, so if there is some over force happening, the neck will bend. The torsional force won't be transferred to the mini pins. Okay, everything goes in smooth effort. This is the hex driver used to open and place the cover screw over the body of the mini pin. So that's all about it. Okay, simple armamentarium. You don't need anything major. So planning a surgical guide, how does that work? In general, you have seen the 5 steps. Those are the same 5 steps followed here. Okay. We plan the location of these mini pins based on the superimposition of intraoral scan with cbct. You can see bicortical penetration, 2 to 3 mm of TADs coming out of the second bicortical plate. Right. And then you design surgical guide on top of it. Now see the opening here. The black line that you are seeing on the torque driver, when you're finally finishing the placement of the TAD, you'll get a vertical stop from this border, and that black line should be seen from here. You just move a bit and it should be seen directly. So this part exactly matches the digital planning. You don't get crisscross placement or rotated placement. You get exact facial surface facing the front side. So we are trying to take the whole procedure. Currently, it is a 2-step procedure. You place the TADs, you rescan, and then design the appliance. But we want to take it to 1 step. Okay. Design the surgical guide, place the TADs, place the appliance the same day. Right. So let's see, more hard work and more amount of refining the process would eventually take us there. And there is a bit of opening here. So when you are placing the TAD, patient is in supine position. You can just see from the top, and you can see exactly when your driver reaches the base of the pallet, and you know that yes, it is about to be stopped now. So you can synchronize that a black line is being seen from the slit opening here. And even if you keep on pushing, okay, if you keep on rotating, see, these are plastic 3D printed. First they'll bend and then they'll break, but your TAD will go more inside. And when it comes too much close to the soft tissue, some amount of soft tissue overgrowth might happen. So we want to avoid that, and we want to be really gentle and not apply too much of force and just keep on placing the TAD. So this is a small video showing on Typhotont how we place our TADs. Okay. So this is FDM printed model. Okay. See the surgical guide. You can see the 2 openings here. Okay. Now you can keep occlusally open guide, or you can have occlusally closed guide. These vertical slots that you see here are for visualizing this. When you place it in, there's a black line here, which should be seen from here. See very carefully. You can see a vertical stop that is preventing the driver from going more in. Check out here. Okay. So you are sitting right 12 o'clock to the patient. You just look a bit up and you'll be able to see that, the black line is seen and it's about to finish. Now you can have a complete covered guide like this, but sometimes it lifts off and we don't realize. So I like to keep an occlusal open guide. And I put temporary flowable composite, TempFill, or you can use your zinc phosphate or zinc eugenol cement, whatever is available in your office. Secure the surgical guide in its position. Generally snaps in its position, but use a cement, and you can see the adaptation from the occlusal surface that yes, it is seated properly in position. So we keep it occlusally open. Fine. Now, these are the two slots in which we'll start placing it. So this is the torque, right? A ratchet. Place this in here. See the black lines? They should be seen from these slots once you finish the placement of the tabs. Okay. They would exactly, these black lines are exactly in the center. Okay. It will fall easy. There is no rubber stopping there. So we have to be very careful in patient's mouth. Okay. So because the surgical guide in itself is really tight, and if you keep a rubber coupling in between to hold the tad, you cannot tilt like this to remove it from the head of the tad. It was becoming very tight, so we had to keep it loose. Second, out is written here. Okay, it should be facing you when you're sitting 12 o'clock to the patient. The out written on the ratchet should be facing you. This won't fall. So there are not multiple parts that will just keep falling. Rest assured of that. Fine. You place the tags without the cover screw. Fine. Now, say 12 o'clock to the patient. That is how I'm right now, 12 o'clock, right behind the patient. Okay. Use the ratchet and see the opening here. Let your tad slide from that part. Okay. See the way I'm taking it in. Okay, you just go straight. It's vertically facing up. Go a little in from that slot. Just take it in. So even if it falls on the back side of the surgical guide. Patient doesn't swallow it. Now, with your left first finger, hold the ratchet in place. Okay. With his second finger, support the surgical guide and simply rotate it like this. This is all you have to do to place the tabs. Nothing more. This is how simple it gets. See the way it easily goes in. Because it's an FDM model and we have printed it full solid. So currently we're experiencing some force. Can you see the ratchet bending from here? See. So what you can do is, if this happens and you want more torque, you can just tighten this from behind after removing the ratchet. I'll just show it to you. Give me a moment. See how easily it is going in. So if you go too much, zack, 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 it will bend. Excess force and torsional forces will not be transferred to your tats. That will keep your bone intact. See, this is how it will bend if you apply too much of force. If you want more torque, you just rotate it, and there is a scale given here. There is a marking which will rise up 15, 20, 30, 40, 50, 60, 70, 80, 90. Those are the readings. And I hope you can see the marker that moves up. So we just increase the torque. Now see how easily it goes. We just reached. And we finished it. Because it's a fully solid model, so I had to apply a lot of force with very heavy torque. I should have printed the model hollow. It would have been easy to place. Okay. So now once this is done, you remove the ratchet. Okay. Take your wing guard. See the black line that is visible from here? You see exactly visible from the slot? That is where you stop. When you come near, you become slow and you see that vertically, sorry, my bad, I just, okay, I'm sorry for that. Yeah. Okay, you can see the slot here. Yeah. Sorry, in excitement, I just pushed my mouse a bit away and the slide changed. You get a vertical stop here. Get a vertical stop here because of this ring. Sorry. Now, how to remove this? you need to get a wing guard. Either you can just pull it, but it would be difficult. See, it's very tough. Second, the surgical guide is very snap fit in position to the round so that you don't tilt it while placing. We want things to go as straight as possible. You get a wing guard or a hoe and just hold the surgical guide and remove it. Simple as that. Vertically and a bit wiggle and it will come out. So the same way we can place the second tad also. Again, the out has to be facing you, facing the side where you place your tad. It won't fall. Here's the marking. This is what you move so that you can improve the torque. Right? So you hit from behind, it won't fall, but if you wiggle it, it will fall. So be very steady while you're taking it inside and placing it. In general, it won't, but if you wiggle it, it will fall. So it's just there, in size. Fine. I hope that demonstration was clear. Make sure you don't drop it and the patient doesn't swallow it. Fine. So now it's going to be the second point. I'll just forward it a bit. Same way. Okay, we just remove it. You see the black line and the vertical stop. You see the black line. Yeah, you can see it there. Here. And this is the vertical stop that happens. Black line and the vertical stop. The ring comes just in contact with the 3D printed guide, just touches enough, and that is where we stop. Take the wing guard or the hoe. I'm trying to show it as if I'm sitting 12 o'clock so that it gives you a proper idea of how difficult it's going to be. So hold the surgical guide, remove it. Take a probe because you have used temporary cement to cement it. Just remove the surgical guide. And there. You have good, nice placement of two tabs. Can you see the facial surface right in the direction that we want it? These are small attempts to taking things single step, but we are still getting a variation of 0.2 to 1 millimeter in all three planes of space for the placement of these tabs. So let's scan. So now when we are scanning, not all scanners, right? Let's start. Okay, not all scanners, okay, can scan the tags properly. So we have designed scan bodies for the same. You place the scan bodies. This is the starting of the scan. We are scanning the FDM printed model. Okay, we'll first scan the arch completely. We cannot see things clearly, so I'm turning off the color so that you can see the scan clearly. It's just a normal scanning procedure, but we do the dental arch scanning first. Okay. Just usual around 30-35 seconds and your scan is done. Buccal and palatal side. And we have placed scan bodies on tabs. I'll show you scan bodies further ahead in the presentation. Okay. So because they are bigger in size, it's easy to capture the size. And in the software, we superimpose the scan bodies. And that would give us the idea exactly what is the height, depth, and position of our tabs. So when we design an appliance, it just snugly fits because of these. Nowadays, the scanners have become really good and you can scan the tabs directly, but initially we had some issues. I'll show you those issues also. See, we're trying to capture as much of data as possible, right? Now, what we do is we go to lock surface. Different scanners would have different options for this. Check out what your scanner menu likes to call it. Trios calls it lock surface. So what is lock surface? When you take a scan, see if it doesn't stay connected to the soft tissue, and when the scan is post-processed, it will delete a part of it. And we won't get the exact location of our mini pins, right? So what we do is we take lock surface and you do like this. So even if you take further scan, whatever is covered in this blue color, that data will not alter. Even if you post process it, the data is good and it will remain as it is. So I like to do for scan, take as much of scan body record as possible, fine. Then lock the maximum part of scan bodies. And it's going very slow. I didn't want to hasten things up and not convey the procedure perfectly. The maximum part is covered with blue so that it does not post process or delete it or alter it. Couple of millimeter of gingiva around the tabs are also marked, so tad won't be affected, the scan body won't be affected, but gingiva around it gets deleted. Again, no point, right? So some amount of palette and the scan body and tabs, whatever is scanned. Now, still again, I'll go and try to scan in that area. So if there is some data which was not captured properly, will get captured. Because it's difficult for scanner to go in the undercut and scan, right? So some part would be missing like this. It'll stay open. Post processing, it will try to close those holes. So now again, we do a bit of scan because I want the data here. I want as much of data possible here. So we do done and we try to take scan again because we want to cover this part also. So I try to move and bend my scanner in all the directions, trying to cover as much of undercuts as possible. Yeah, and now we send it for post-processing. I know it sounds very tedious to do that, but if we don't get the accurate positioning of the tabs, the appliance don't sit properly. Just we do next and it'll post-process. So take a bit of time. Let me fast forward it for you. Yeah. So that is how we get the final model with scan bodies, tabs at the bottom. We just take it to the appliance designing. Fine. Now say you have a very nice scanner that would catch your tabs pretty well, you're confident about it, then we don't use scan bodies. We don't use scan bodies, right? And always, whenever you are doing a color scan, see there are windows here which are not scanned properly. Can you see? Just convert it to black and white. Okay. And you will be able to see that your data is perfect or not. Now let's try to scan the tags directly. I don't know why it is not starting on its own. It's the same scan, right? Now see, we start seeing tags. Now personally you will find the tags are getting very easy to scan. Why do we have to go for scan bodies? Because I'll show you in the next slide, at times if you don't capture the tags well, okay, the appliance design fails. So check out what works well with your compatible scanner, the scanner you have in your office, whether you want to scan with scan bodies or without scan bodies, both the options are available. All you have to see is these margins, the definition of tags, and it should be connected to the soft tissue so that the AI of the software doesn't think of it as gingival extension and deletes it before processing it and sending it to me. And that's how you record almost everything. And again, in the same way, once it is done, you lock the surface. Lock the surface. See, that's the procedure I'll show you right now. We check the scan from all the side and then we lock it. Okay. Once it is locked, we take it for post-processing. This is how we get it. Here I've got good definition of tags, no doubt. Let's switch off the color so you can see. But see, you see this part? Because it was not connected to gingiva, it was only connected to, to the palatal mucosa, it was only connected on one side. It auto-deleted and filled the hole like this. So at times, scan bodies, they prevent this from happening. Now, what we do is we generally take tags and we superimpose it on this so that when we are designing the appliance, it feels that the real tags there and it does not create the appliance in the undercut. Okay. So when you are scanning with tags directly, okay, what happens is, see here, silver and golden color, different iteration. Now golden doesn't scan that beautifully, doesn't get scanned that beautifully. Silver one is pretty decent in being recognized by most of the scanners. But see, this is the change. If something like this happens and we design an appliance in metal 3D printing that would be adapted here, in patient's mouth, it's not gonna fit only. Right? So we need good marginal definition of tags in the scan. Please check it thoroughly every time. Yeah. Silver and golden color. So golden, pink, blue, they were not that great with scanning, but silver worked beautifully well every time. And that's why the current and final generation is silver in color. Yeah. Okay. So once we did the scan, we have to we design the appliance around it, and then we have to place it on the typhodon. So let's see how the appliance is placed on the typhodon. So these are the cover screws that will go in this. This is the appliance that is designed and printed. There is a slide where I will show you the design of appliance. I think I've done it up and down, or the slide got misplaced somewhere. See, this is printed in plastic, just for the demonstration purpose. Okay. See, this is how it will snap in position. Simply. And now, just place it. Let's take the cover screw. It won't fall that easily. Not like our tags, it will stay in grip, nice and firm. Same way, you can see there is a vertical extension in the side of the tabs. Yeah, here. So even if you over tighten it, your tabs cannot rotate. So there's a vertical stop, it prevents it from rotating. You have extended the body in the lateral surfaces of the tab. It can be on any side. It is one wedge that will prevent when you're tightening the cover screw from the top, it will prevent the tabs from rotating. You can see here vertical extension and the appliance in between the cover screw and the body of the tab. So this prevents the appliance from going in. Now, if you're doing clear aligner therapy, you can have a button like this on the buccal side. If you're doing fixed ortho, you can have a round buccal tube or laser weld your rectangular buccal tube on these metal printed bands. This is the side from where you activate the hyrax to initiate a distalization. The hole always comes occlusally. So it is easy for patient to rotate it, and the rotation always happens on the inside from both the sides. That is how we have to digitally plan and place the hyrax. So it is easy for patient to do the activation themselves. They should not need assistance. Most of my patients do it themselves. Okay, so let's see how this appliance was designed actually. Okay, so you have the scan. Okay, you superimpose the tabs in the position so that even if there is slight defect somewhere like this, the software considers the actual shape of the tab and the appliance is fabricated in these dimensions, so it can fit easily. Now, this is the appliance. This is the metal framework. The blue color is the metal framework that will go in metal 3D printing. And this is where the slimline hyrax will be laser welded once the 3D printing is complete. Right? Now, if you want to do fixed orthodontics, okay, these parts would be cut after the hyrax is laser welded. They'll be laser welded here, and that's cut. So now these are the bands. First and second molars are connected. You can keep it open from the buccal side and bond your buccal tube here if you're doing fixed ortho. If you want a buccal tube in the band itself, you can 3D print a round buccal tube, or you can take your rectangular buccal tube and laser weld it on the surface of the band. Either ways, your choice. All the options possible. But if you're doing clear aligners with any company, you can create a rectangular attachment like this on the buccal side. So once your distalization is over, you can put aligners on top of it and you can start retracting the anterior teeth for spacing and closing. This acts like an anchorage, having kept this in place throughout the treatment. So So this becomes TAD supported anchorage while you're carrying out your fixed or aligner therapy. So the idea here is instead of putting the TADs on the buccal side, manually placing it, and mortal like me failing so many times in placing these TADs, or patient coming with the swelling or gingival coverage coming on top of it, somehow I was not getting the hang of it. So I wanted to make things foolproof, FOOL proof. So it is I call it I'm foolish and this is my device, because it keeps things simple, nothing heroic, no talent required. So yeah, okay. Some of the slides have become up and down. I'm extremely sorry for that. Now, once you have placed the TADs and you have taken the scan, okay, these parts will hurt the patient. If you send the patient home just like that, these parts will hurt the patient. Okay. So what you do is you use, they'll hurt. Okay. They're really sharp. So you use something like our Temp LC Flow. It's a silicone type temporary filling material. And you just place it in here. The two slides have been misplaced. I'll correct it right in front of you so you get the sequence properly. Okay, and then you just cure it. They are light cured. There's something like SoFlo from Dentos so that your darts don't hurt the patients. I didn't realize it initially, and my first two patients had really good lacerations on the tongue, and they came with complaint of a lot of ulcers. So then I started placing this. Always check it that it's not getting peeled off easily. Otherwise, patient will leave the chair and this is a temple. It will just come off and the patient will swallow it. So no problems in swallowing it, but then it will start hurting. So make sure it stays good in place, right? And in the next appointment, when you want to place the appliance, you can just take a tweezer or a probe or something and you can just lift it and peel it off. Or you can just take a probe and move it and it will just come off easily. So once you place the TADs, you take the scan, then you have to send the patient home. That is when you do this, right? Then the appliance gets designed, which was the previous slide. Then the appliance is fabricated and placed in position. At that time, you remove this. Okay, it will just come off easily with a probe. Simple. And take out the whole piece in one shot. Yeah, that's all. So there are different distalizer appliances possible. You can have unilateral or bilateral. You can have biocreative appliances, like if you just want to uh, palatally tip the overhanging cusp or something, you can use this. You can use it for intrusion, or if you want something for retraction, AP retraction, you can use like this. Or if you want to do intrusion by applying forces from buccal and palatal both the sides, you can use something like this. The best part is open the cover screw, the whole framework will come out. Place the framework and secure it with the cover screw. So the framework is sandwiched between the two parts of the TADs. So it prevents as much of cantilever and bending as possible, because the appliance is manufactured with COCR alloy, which is 10 times more rigid than any stainless steel. They're very rigid. Fine. And TADs we have placed with bicortical anchorage, so we're expecting them to be really sturdy. Or you can have something like hybrid Hyrax, or just bone supported bone-borne Brolax, or quad expander. Now this is something new and interesting. Okay, quite a few of us are aware about this, but this is not something new. I have seen it a lot happening on the social media, and how different it is from our normal 4 TADs market. Okay, so what happens here is you see the oblique positioning of these two TADs. These are placed in the bony wall between the sinus and the nasal cavity. I'll show it to you in the next cross section. So when these TADs are in the oblique position and when you start expanding, because of the horizontal shelf on the head of our implants, like this, okay, the appliance is going to apply force like this, in this direction. So your anterior TADs are applying force like this for expansion, and your posterior TADs are applying force like this, pushing it from the head like a hammer so that the split happens. And obviously, if you see on the posterior side here, if you place your TADs vertically, the posterior one, see the amount of bone they get. Hardly anything. Okay, the amount of bone you get here is hardly anything. But if you put it here, this is the nasal cavity, and this is the sinus. Okay, here, see the amount of bone it is going to stay in. Good amount of bone, right? And this is the quad expander. So I have not used it in any patient so far, and I would definitely like to try it once I get a chance. And hopefully soon, and success or failures, I will discuss it with all of you as always. So life ain't easy. There are lots of work goes before introducing something new to the fraternity. It was not like I saw such ads happening outside India, not available in India, and I jumped to the opportunity, make something similar and we'll sell it to everyone. No, things don't happen like that. What everyone sees is the tip of the iceberg, but what happens behind the scenes is you try a driver without torque, balancing, single force, then you understand the value of this, you improve it and get a torque manipulation possible. Let me get this thing here. These are the different drivers that we have tried. Difference in length, we thought it was just little big. We reduced couple of millimeters. We introduced the arrow in between. We changed the color to see whether it is easy to see if we have a brighter color. Lastly, when we change this torque wrench, you can see the difference in height here. That is why there is some difference in height here. Otherwise, this length remains constant with this. So this is 1, 2, 3, 4, 5 iterations of just one driver. 2 iterations of torque ratchet. And see the amount of iteration in TADs. We started with hexagonal just to realize that it's going to wear off our driver very fast. Square is better. It gives us more surface to get more support on the TADs. We shifted to square. Okay, that's the square. Then we tried different colors, which scans properly. Okay, 1, 2, 3, 4 colors, which scans properly. You can see the difference. There is a notch here for easy self-drilling, tapered point, and the final one, we have smaller notch, but broader threads throughout the body and a little longer screw. Fine, and it's not just in the TADs, we even change the shape and colors of the heads to see which one works better. We started with a simple hex driver, then shifted to this one, and not to forget the scan bodies. So lots of iterations and studies have been done over past 2.5 to 3 years. It started pre-COVID, just with an idea of trying to convince a distributor to import TADs of certain company to India. Everyone was closing doors on me. No one was interested, and everyone was like, there's no market. But I wanted to use it. And that's what I'm trying to display today, that I am finding it very useful. Are you finding it useful? If so, do get in touch with me. It would be very nice to work together. So guys, that's D3D TADs for you, digital 3D TADs. I know it may or may not sound good name for it, or might be it's too funky or catchy, I don't know. I just like the ring of it. That's me. You can follow my work. And an idea is worth millions only if it's executed, right? So that's what I have tried to do. I have tried to execute my idea, and hope you like it. That's good day from me to you. Bye-bye. See you in person soon.